Let's talk about array unbounded queue class. This is very close to array list or a vector, either Java or C++, giving you the ability to dynamically resize the array. So in the previous implementation of using array fixed size queue implementations, that size is bound to either a cap size you specify or a max size that you specify. Once said, that entire fixed array does not grow. But this one does. Similar to what a vector is implemented in some programming languages, there is a enlarge method. The idea is once the array is full, the program allocates another array, doubling the size of the previous one. That doubling mechanism is predicated on which programming language you use. The implementation is a little different from language to language. Every time you want to expand the fixed array to having additional space to it, you can either by doubling the current size or just add a fixed capacities to it. Now, let's just say if your old one is overcapacitated, and by enlarge, it means that your program has the ability to add some extra space to it. So in this case, it could be doubling the original one, and then just copy the elements from the old one to the new one at a time. You want to utilize this enlarge mechanisms to expand your fixed array into another new size and copying the old values into the new one. Very slow, expensive propositions here. You don't want to keep growing this. You perform some sort of due diligence at runtime to ensure that your queue enlarged by a fixed capacity. We will have to also change a couple of the observers so that, for example, the isFull method for the unbounded queue, because there is no bound, it should always return false. This isFull is not needed. We still need to use the isEmpty methods and the dequeue. So dequeue part does not change because we only care about copying what we have into the new queue. And these operation is going to change the in-queue indexing side, keeping track of your front. The dequeue and isEmpty are both unchanged. So let's just talk about the high levels right now. This is the beginning part of your ArrayUnboundedQueue class. This is a concrete generic class that implements queue interface T. The default capacity is the same. Number, element, front, and rear, we defined this already. So this original cap is the original capacity. We want to expand our queue capacity by this amount every time the original queue is full. Your rear is going to be at the end of your original cap -1 because indexing starts with 0. And you want to keep track of your original cap here this way. So this is a member variable as a protected. For the default constructor, the original cap is set to 100. This is how you instantiate your ArrayUnboundedQueue class. Let's just move forward to in-queue operation and see how adding elements to this unbounded collection is going to have impact on the whole system. And let's say this is your entire queue, and your original queue may have only 100 elements in it. Your num elements has already at capacity, meaning you can't in-queue anymore. So this used to be isFull, right? But isFull is always going to return false. If number elements are already at elements length, at capacity, you want to enlarge. This is a member function that allows you to expand this entire capacity by a certain amount. So that enlarge is responsible for doing this. Enlarge as this amount right there to the end of the original. You basically have to create a brand new one that's of this enhanced size. We will have to copy what you had from your old queue. Basically, I have to copy everything into the new one like this. The operation here for enabling this is detecting whether you need to enlarge or not. If you do, then you have to create this entire new array. The second operation is to copy. One is creation, instantiation of the new one. The second one is copying. Copying is O of n, creation is O of n. Creation is O of n in memory because you have n number of elements that you have to add. That's essentially 2 times O of n. We're keeping the rear tracking, the element tracking, as well as the number of elements the same. So in queue means adding this element. Elements rear equals element says that you are adding the elements at the rear, and rear equals rear plus 1 mod element length is the same. Just by adding this, two elements lengths does not change. This element and this element will be different. And the reason is there is an enlarge here. Inside this enlarge, this element before the enlarge would have been the old element. At the end of your enlarge, this entire new element would have been the new one. This element and this elements are different. The top one is the old one. The bottom one is the new one. Previous slides. So this is a little complicated to read. So let me visually illustrate this. This enlarge increases the capacity of the queue. You have this old one. You're going to add the original cap to the elements, creating a larger array. So this larger array is from here to here is the original cap, right? So this original cap could be 100, could be 200. This is the additional capacity that is being allocated. And the creation of that entire large array is here. This establishes a brand new one when you are at capacity. Your current smaller equals front. It is very possible that your front is already here. This is your old front. Because you want to copy old value into a new one, make sure that your front is starting at 0. So there's some sort of transformation going on here, transforming the coordinate, this f, into a 0 indexing. So what you need to do is unfold or undo your full floating design into 0 base design from 0 all the way on to original capacity plus elements length. You're looping through your current larger. So current larger is your indexing from 0 all the way through number elements. This is your old element from here all the way to here. Current larger 0 is going to have f. So the very first one, current small. Current smaller is front. This is called larger. And the old one is called element. Current smaller equals smaller plus 1. So recall that this line of code is the same as what we had before using the modulus. This is the old floating design that wraps the front through this. While this loop is going on, sliding f all the way through, f plus 1, then an f plus 2, you're going to be at the end of the old one. Well, you want to make sure that this f plus 6 sits here. So this is the algorithm, small plus 1 elements length, because the copying takes the small to the larger. Current larger is always going to be expanding. While this index current larger is going to expand, your current smaller is going to wrap around this element by length. So this entire loop is going to start from f all the way through to the n, and then it kind of circles back from the n all the way through to the f minus 1. And that loop goes on with the current larger index right here. This allows you to unfold the floating array element, starting with front being the very first guy, into this larger array space. Elements. This used to be the old one. This old one is going to be pointing to the larger one. And so now your protected variable elements is pointing to a larger one. The old one is going to be garbage collected because you no longer point to it. Now your front is going to be at 0 because you set front to be 0. And then your rear is going to be numbers elements minus 1. So what is num elements minus 1 then? The num elements minus 1 is going to be at the end of your original one. So number element is still the original side because we haven't changed it. And then your rear is going to be here. Let's just assume that there was maybe like 5 elements. But the point is that we're resetting front and rear by unfolding what we used to have from this smaller array into the big one. DQ is exactly the same. isEmpty is exactly the same as well. And that is basically it, the array unbounded queue. I'll recommend that you go through this entire class in your modules. Make sure that you play around with this and understand the implementation details.